All right, thank you everyone, and welcome to another great session. Now we have a really cool duo for our next keynote, and this keynote is about pushing for collaboration to propel digital twin forward. And here to talk about it, we have Anandita Punj, service designer at Info, and Art van Kreeke, the founder of Growy. So please welcome our two keynote speakers to the stage.
Is it working? Yeah. Okay, so hi everyone, and welcome to our talk. Before we begin, we actually want to show you a small teaser about Growy before we start diving into what digital twin is and our experience applying digital twin for Growy's use case. So let's try.
Vertical farming gaat echt een onderdeel spelen van de hele voedseltransitie. Alles is robots, alles is data, alles zijn sensors en AI, terwijl we eigenlijk gewoon aan het telen zijn.
Yes, everybody, welcome. I'm Art van Kreeke, owner of Growy. Growy is a vertical farm. We grow plants. So probably you wonder what are you doing on a software event. Well, I hope we make it clear in the next session. We are really, for us it's about changing the food system. We are really part of a bigger plan. We want to create sustainable, healthful and affordable food. And we do that on 3 promises. Most important is tasty. Nobody's going to eat more vegetables or salad if it's not tasty. And with our background of serving today a couple of 100 chefs, we know what tasty should be. Second is healthy. Healthy, and not just for the plant, but also for the people who eat it. So it's about nutrition, it's about the value of the consumer, but it's also about the planet. We make it sustainable, we make it climate neutral. So climate neutral farming is what we do. And of course the most important problem is the affordability. We don't want to make a high-end tool, we want to feed the world. We do that in a fully automated and really AI software basis. We work with machine learning, we do it all, we really manage a whole farm with robots. No human interface is needed. And we do that to create high nutritional values, to create very high quality, and to get really high production yields. That all comes back to the first 3 promises. And of course we do it with machine learning, machine doing. So really everything is automated. The seeds come into the plant, the robots pick it up, we seed it, we grow the plants in different phases, in different climates, better climates than it's here for a speaker, and that's how we get high yields and high quality plants. We also do that, as I said, fully circular and affordable. Those are really important key issues, especially with all the talks lately about sustainability food, about food security around the world, about the climate. We think we can really make the difference in that. We are the world's first closed-loop vertical farming, and closed-loop means really circular. So we take food waste from the clients, so we deliver salad to Albert Heijn, we take the Albert Heijn food waste back, we deliver salad to restaurants, we take the food waste from the restaurants back. We unpack it, we clean it, we use it in a digester, we get the water, the energy, the CO2, and that's how we make our food. And we do that with a very low capex. The whole plant is designed in-house and developed in-house, and we have a very low cost price compared to other vertical farms, so we can make it affordable. And to make also the operation costs very low, we fully automate it. And to make it scalable, it's really software driven, so we can copy-paste it around the world. We're not going to feed people in Holland, there's a lot here, but we really want to go to Africa, India, these kind of countries. We have 2 types of concepts where we explain how we grow our plants. One is the Growy farm, which is a large-scale retail solution where it's a kind of salad factory, where we can really produce all kind of herbs, all kind of leafy greens, but also strawberries in the future, water lentils, potatoes and these kind of things. Large-scale things we put as close as possible to the consumer. So preferably, as the picture here on the left says, in a distribution center of a retailer, we need 1% footprint of that distribution center to produce all the leafy greens that they have. Because it's fully automated, there's no people needed. So the retailer really, on one end, we put in the seeds, and on the other end, the packed salad comes out directly into the truck, directly to the supermarket. So a very close chain. But also we need to introduce it to the consumer, because at the end, the consumer is of course the client, and the consumer needs to be convinced that this is the way to produce food for the future. That's why we created an urban food hub. We call it our Growy house. The Growy house is all about getting people involved in food again. People can come and visit it. People can see it, feel it, but more important, they can taste it and really see, okay, this is how salad should be grown, and this is how healthy food that is good for the future is being produced. We want to build Growy houses in all the big cities around the world. Again, coming back to the circularity, what's funny is we use organic waste, which is widely available, and not only in Holland, but all over the world. It's widely available. We use it to put it in an anaerobic digester, and by that we create our own energy, but not just that, we also create our own CO2. So we have neutral energy, climate neutral energy, but the CO2 that we exhaust, we use to feed to the plants. Plants need CO2. So we are at the end, we are net positive on our CO2 footprint. So out of the digester we use energy, we use the CO2, but we also use the water and the nutrients. That means at the end all we need is seeds. And the rest is all locally in a circle produced. We do that in a Growy cell. A cell is the concept that we created, and these cells in a large-scale farm, we can put 20, 30, but up to 100 or 200 of these cells at a local distribution center of a retailer. And the cells are fully autonomous. In each cell there are robots running up and down, and all we need is a mechanic to do maintenance. The cells are placed at the distribution center, and in a complex of cells with 40, 50 cells, we have a seeding line, a harvesting line combined to it, a climate system combined to it, and that's how we create a farm. But the basis is the cell. And what's important is zero waste. It's very water efficient. We use really 95% less water. It's circular, as I said. It's energy efficient. Lights can be adjusted exactly to what the plant needs. And it's fully automated, as I said. So all this together makes it a very efficient solution. And it's also clean. So we don't use any pesticides. We don't use any chemical fertilizers. It's really clean. Of course, we cannot do that alone. So we do have very good collaborations and partnership. One of them is Info, of course, as a software house, also very intense contact with all kinds of universities around the world. Mainly Wageningen, of course, that's our key partner, but also TU Delft, TU Eindhoven, and around the world we are setting up a network now. We are talking to the National University of Singapore, the NAS, we are talking to universities in the Middle East, in Dubai, we are talking to university in the US, left and right side. So it's very important for us to really work in partnerships together to get this accelerated and grow. So that's it for my part. And as it's all software and digital, we continue with.
Thanks, Ard. Okay, so now we're going to come to the section of the digital twin. And I'm just going to take a step back and give a precursor on what really a digital twin is. So there are a lot of manifestations out there in terms of what a digital twin is, but a commonly agreed upon understanding of what a digital twin is that it's a virtual construct of a physical object. And if you think about how that really happens is, you think about a plant. So the virtual twin would have the same attributes as a plant in the physical world. So the color, the shape, the size that you see for a plant in the physical world, the virtual twin would have those exact characteristics. But it's also very closely tied to the life cycle of the plant, of the plant in the physical world. So if one of the leaves of the plant would wilt, the virtual twin, one of the leaves of that plant would also wilt. But the digital twin is not just limited to one product or just one component. It can extend beyond that to virtual systems and virtual processes. So in the case of Growy or in the case of a plant, you can extend the virtual construct to the gutters and the farms where the plant is placed. So you could have a digital twin of the farm and the gutters, but not just the physical objects, but other aspects such as the CO2 around the plant or the humidity around the plant. So that's essentially what a digital twin is. And you actually would be wondering, how do you actually create that digital twin? Well, digital twin is not really one technology. It leverages a lot of other technologies to actually make a twin. So to ideally get all the characteristics of the physical object, you would tap into IoT and sensors to actually collect this data and feed it to a virtual system. You would tap into 3D modeling capabilities to actually build and visualize the data that you're getting about the physical product into the virtual environment. And if you add in a bit of machine learning or AI, you can actually automate this whole process, not only to bring data from the physical system to the virtual environment, but also flow the information back from the virtual system to the physical product. And that's when you have a full-fledged digital twin. Now, one of the reasons why digital twin became really popular, and if you read Michael Greaves' paper, you would know about the 3C concept. It's essentially that digital twin helps you conceptualize, collaborate, and compare. How does it really do that? And why? What does it really do for you is that it helps you conceptualize remotely from anywhere what a physical product is doing and how it's behaving. But it also helps you to conceptualize new behaviors, but also new ideas. It also helps you to collaborate better as a result of visualizing all these physical products remotely from anywhere in the world, so you can collaborate better with the teams internally. But also, when you add in AI and ML, you can compare not only the current states of the product from the past to the present, but also future states of the product. So a lot of people then wonder, like, okay, how exactly does it do that? Like, how does that really happen? Because it's a combination of multiple technologies, it helps you get to levels where you can actually start collaborating and conceptualizing better. So when you tap into IoT and data management, you can actually start monitoring things remotely from anywhere in the world. The moment you add a layer of data analytics, visualizing that data, and you add versioning to it, you can start comparing the whole product along its life cycle. And when you add all this data and feed it into machine learning models, you get to a stage where you can start building models to start optimizing your process, because you can overlook how the whole system is really working. You add AI to it, you get to a stage where you can start making future predictions and simulations. So this is all just basic theoretical stuff that's out there in literature of what digital twin offers. And when we were working with Growy, we were trying to understand why exactly would we start working with digital twin, or should we even look at digital twin, or should we consider that? So for us to start tapping into that, we started looking at what are the goals for Growy, and one of the goals for Growy was that it wants to be completely automated. It wanted to offer farming as a service, so that means they had to be remote and manage the farm from literally anywhere. At the same time, one of the goals for them was to be adaptive, not only towards the context in which they launch their farms, the customers that they're serving, the market, but at the same time also be adaptive to the needs of the plants that they're growing and the needs of the farm. So we knew that digital twin is one of the ways for us to move towards a business model such as FaaS, because you're farming already, but how do we create that as a service? And that's when we knew we could kind of see some kind of synchronization with what digital twin offers in terms of outcomes. So not only that, as a result of tapping into ML, we knew that there's a way for us to do process optimization, which works towards one of our goals of becoming more circular, making sure that we can optimize the processes of how much resources we use from water, energy, etc. So the challenge for us was that, okay, we see that digital twin is something that could really help us get to our goals and outcomes and our vision. But how do we actually get started? Because there are so many technologies out there that you can leverage for digital twin. So we decided to take a lean approach because we had to get started somewhere. So the digital twin really acted as a North Star for us. And we decided to first set up the hardware systems around the whole farm, the plants, to actually start collecting data first to understand what's really happening at the farm. So we tapped into IoT. After we tapped into IoT for collecting all this data, we wrapped a layer of software around it to actually start understanding what this data means. So we tapped into creating data analysis from all this data that we are getting in. At the same time, there's no point of us collecting all of this data if we can't send some information back to the farms. So we tapped into robotics to actually automate the whole process of how we are farming. So that was another technology that we decided to tap into. And now, after so much data is being collected, we are making our way forward towards building machine learning models to understand how can we actually get to desired outcomes, which is increasing our yield, making better plants that are tastier, while still retaining, while still ensuring that we use less of water, save each drop of water, and are using less energy. And that's what we are working towards with machine learning models. And as we start moving forward from that, we might tap into 3D modeling, object recognition, or AI going forward. So a lot of people come to us and they say, OK, so you have a digital twin, so you'll have like a big model that we can look at, like a cool 3D model. And I'm like, oh, sorry, no. We actually don't have that. We have this dashboard. But essentially, this dashboard lets us tap into all the 3 C's that I talked about earlier. It helps us to conceptualize, it helps us to collaborate, and it helps us to compare different aspects of the farming that we're providing as a service. So how exactly does it really do that? So if you want me to go into depth, right now with this dashboard, which we call the plant manager, you can oversee the whole process from seeding to harvesting. But not only that, you can see the whole farm setup. So we can actually essentially navigate to different parts of the farm located in different parts of the world. The only difference is it's not a 3D model. We have an information architecture set up to go into those different aspects of the farm. But not only that, we have all the data when it comes to climatic conditions within the farm. So how much CO2 level we have, how much humidity we have. But also, we are collecting data on how the plants are performing. So what is the height, what is the yield. And although we don't have a 3D model, we wanted to still leverage the power of visualization within our dashboard. So even though we don't have a 3D model of the plant yet, we do have data collection happening from the robots that captures the different images of the plants at each stage so people can really understand and triangulate between data, text, and visuals of how the plants are growing. We've also used robotics to completely automate the growing phase of the farm. So everything from putting the gutters to giving water to the plants is actually happening through robots. So we have twinned different aspects of the farm in different varying levels. So the farm, the cells, and the bots. And none of them are 100% twinned, but we are working towards making it a 100% twinnable concept. So why did we start doing that? We wanted to get started and take a lean approach. But as we are scaling up, we do know that digital twin is going to help us leverage to scale up as well. Till now, we've been using all the data that we are getting to understand the behavioral aspects of the whole farm. So the 3D model is not there, but the behavioral aspects, the identity, the soul of the farm, the soul of the plants, all those characteristics is something that's captured on our dashboard. But now the next phase for Growy would be to optimize the processes because one of our goals would be to increase our revenue, but also reduce our costs. And you would do that by optimizing your current processes in terms of how much resources you are using, but also increasing your yield. So how would we do that? The first thing is that we have been collecting data over a period of time to work towards machine learning models. And why would we be doing that? And why do we want to leverage machine learning? Well, we have different aspects within the farm. So if you want to optimize the farm, how do you actually work towards maintaining the yield that you already have, or at least increasing the yield while maintaining the quality of the plants that you're growing across the life cycle and making sure it doesn't increase? There are multiple parameters and digits to the points that you need to work with, which makes it a little bit difficult for humans to kind of work with. And that's where we are going to tap into machine learning and AI. But not just that, when we are in our experimentation phase with the plants, there are a lot of chances that you'll have unwanted growth or unwanted characteristics, so yellowing of the leaves. Can we actually leverage machine learning to do early detection of these unwanted characteristics for the growth of the plant? The other thing that we also want to do going forward is that are there aspects that we can still visualize from a 3D model of the whole service or the farm? And the reason we want to do that is that although we are essentially using a software to do it, we are farming at the end of the day. And visualization really leverages and gives us the power to tap into the ability for people from all backgrounds to actually come together and triangulate between different aspects such as text, data, and visuals to actually navigate the farm and understand the whole processes better. The other thing we're also trying to do is that earlier we started off by focusing on the macro scale, so twinning the behavioral aspects, the processes and the systems of the farm, the cells and the units. And we are obviously capturing data around the plants as well. But it's happening at a gutter level. We slowly want to get closer and closer to the plant itself to understand what's really happening at the micro level of the plant. And the reason that we want to do is because at the end of the day, like Art mentioned, we want to offer great plants that you can eat and you can enjoy. So next level tasty, next level healthy, and next level affordable. And for us really to get to start doing that, we would have to start creating plant profiles to really understand how do we tweak smaller aspects of nutrients, create new hybrid models, test new kinds of plants that we want to create. And in order for us to do that, we would again have to leverage the next few technologies that are there on a spectrum map. Now, a lot of people have also asked me that there's a lot of literature out there that says digital twin can really be helpful for you to achieve certain goals and outcomes. But most of them talk about use cases which are focused on physical products or physical assets that you need to have as a company. So if I don't have a physical asset, what if I have a digital service? Is digital twin for me? Can that work for me? And my answer is yes. It can be for you, but it really helps if it's tied towards achieving positive impact goals. So let's say you're a streaming service, and there's a lot of information out there that says it can sometimes cause addiction. How can you use digital twin to leverage you to understand new business models where you retain your streaming services, but also help people understand what actually causes addiction, how should they actually use the streaming services? What if you collaborate with a smartphone company to do a design-led research where you can actually understand how, come up with a hypothesis and be like, okay, this is a streaming service. We want to understand that for what are the kind of people who really get addicted. Is there a way for us to create those profiles? And yes, if you have those kind of positive impact goals, I think digital twin can really help you. But not just that, I also understand that you can actually leverage digital twin for a lot of other sectors. So if you think about sustainability goals, I always think of e-bikes and I think of electric mobility, and I think that, okay, can you actually think about using digital twin to achieve certain goals of sustainability or circularity? So imagine if you have an e-bike, could we create a digital twin of a battery to understand when to provide predictive maintenance? Can that actually help us to tie in into the larger ecosystem, work with municipalities or charging infrastructure companies to tell them that we have a twin and we have understood based on the usage pattern that most twins run out of battery at certain points in the city. So maybe you want to set up your charging infrastructure here. So digital twin not only helps you collaborate internally and reach certain outcomes for your own company, but it actually creates opportunity for you to partner with people in the ecosystem. So we've always seen digital twin as a spectrum when it comes to the 3 Cs. We always keep thinking about how do we collaborate better, how can we conceptualize better, and how can we compare better. One of the challenges that we faced when we started working with digital twin was making sense of the data, and I think most people actually face that as an issue. And we also observed that initially collecting the data is not as much of a challenge as much of creating classifications around that data, understanding how to filter it, and how exactly would it help towards creating machine learning models. An ongoing debate also internally for us is to understand how human intervention would be involved in working and creating the software. Our end goal is towards complete automation, even for the software, so working towards AI. But it's an ethical debate for us to understand how exactly would humans collaborate with machines going forward. Is there a possibility for us to do that, and is there a need for us to do that? So digital twin was a journey for Growy, and we have the 4 pillars around which we had to create alignment to actually get started and push digital twin forward to launch Growy the way it's working and how it's functioning right now. So processes, teams, data, and software and hardware. And when you use digital twin for a single component versus when you use digital twin for multiple processes or multiple systems, it gets more difficult to create alignment. And for us, a way to do that was by tapping into design methodologies of service blueprinting, scenario mapping, to actually align how all of these 4 pillars would work together, but also speculative design to create future states of where we want to be and what we can do to get started right now. Another thing that Growy really tapped into was also making sure that they come up with a way of working, because digital twin is a concept that can't be something you use just in terms of what you produce, but it should be inherent in the way your culture is organized. And as Art mentioned earlier, we also leverage ecosystem mapping, because getting towards each digital twin would require collaboration in the larger ecosystem. Another challenge that we faced when we started working with digital twin, and that's one of the main challenges that I feel out there, is that there are no domain-focused or digital twin-focused frameworks or approaches out there. When we had to get started, we had to come up with our own frameworks to understand how do we really get started, what are the things we need to consider, what are the themes we need to consider. So I always keep thinking, and this is like a burning thing inside us, and we're like, we need to come up with some kind of approaches that can help us really understand that when we're working in mobility or when we are working in healthcare, do we need to consider themes of ethics? Do we need to consider themes of privacy, security? How do you make sure that you don't miss out on all these edge cases and scenarios and themes when you're working and you're getting started with digital twin? Another thing we realized was it would be super helpful if there was some way for us to start prototyping it. As designers, a struggle was that, okay, how do we start prototyping to actually bring all of this together? We are using different kind of frameworks that we've built in internally, but how do we actually start prototyping? When I'm building mobile screens, I use Figma, I use InVision, but how do I do that when it comes to digital twin? You could get started a bit with Arduino, but what we really needed at that time was a prototyping tool that could actually help us put all of these processes together. And something that's probably domain-focused, because when you look at agri-tech, even within agri-tech, there are multiple use cases that you can tap into. And they each come with their own nuances, which is right now missing. The knowledge is missing. And that is something that we want to urge people to start focusing on. Really come together. If you have knowledge working with digital twin in different sectors, share it with us so that we can move forward, and we can share that knowledge with the community so that people can really start using it. And the reason we want to do that is because we genuinely feel that digital twin is the future, but not only because, well, we all know that there are a lot of digital worlds that are coming to life. There's the metaverse. But digital twin is what really makes the virtual environment real, because it leverages contextual real data to actually feed into the virtual environment. So we do feel digital twin is for the future. But more than that, what we've seen is that every time we are working with digital twin, it helps us to move towards positive impact goals. So not only sustainability goals, because it focuses on process optimization, but also focusing on users and working to actually help users as opposed to just using users to make money. If you have a positive impact goal, we really see digital twin helping you to get to that goal in some fashion or the other. So we did have a lot of challenges when we got started, but we know that digital twin can really help people meet their goals if they want to, especially if you're focused on positive impact, social impact, ecological impact. So if you want to talk about how your business could really benefit, or you're not sure if it's really for you, please reach out, and we'd be happy to help you understand if it can provide any value. Thank you. And yeah, we're open to Q&A, and both me and Art will be around. So if you have questions on how exactly we got started or different use cases, please reach out. Yeah, thanks.
Right. Can I get the mic on? Yes, there we go. Thank you so much, Anandita and Art. And yes, they will be here outside. Now we're going to take a 1-minute break just to kind of reset everything. And then we'll be here with a talk about what's actually left to learn about Silicon Valley. And you don't want to miss it. See you in a bit.